Okay, today we started graphing linear inequalities, so we are going to graph linear inequalities either using slope and the intercept or just the intercepts. Alright, our first example, it says determine if the given point is a solution to each inequality. So we have done these before. This is where you take your x value here and your y value here and you substitute them into the inequality to see if it's true. So here we go into the equation. We replace the y with the -5, the x with the 3, and then we solve this. So this reads -5 is greater than -1/3 times 3 will give you -1 plus 2, and -1 plus 2 is 1. So here we read this, it says -5 is greater than 1. Because the statement is true, that this means that this is not a solution to this inequality. And I'll show you on a graph what that means here shortly. Okay, so again, we're going to take this equation, replace the x and the y. Here we replace the x with -2, the y with 4, and then solve this. 2 times -2 is -4, plus 3 times 4 is 12, and then we get 8 is greater than 6. And this is true, so that means that this point is a solution to that equation. So we have here an inequality graph. The first thing you're going to see is the boundary line. The boundary line can either be solid or dashed, and I'll show you the difference here in just a minute. We also get what's called a half plane. This half plane is considered to be above the boundary line, and if we were to shade below here, this would be considered below the boundary line. And with an inequality, you will have shading either above or below that boundary line. So to graph a linear inequality, the first thing you're going to do is solve for y, so it will look like y equals mx plus b. We do that to allow us to identify the slope and the intercept. The next thing you'll do is you'll graph that boundary line using the slope and the intercept. And here is where you will decide if it's solid or dashed. If it has this greater than or equal to, it's solid. If it does not have that, it will be dashed. Okay, then you have to determine whether you shade above or below the boundary line. If it's less than or equal to, we shade below. If it's greater than or equal to, we shade above. So here we go. This equation here, it says to graph using the slope and the intercept. This is already in slope-intercept form, so we can pick out the slope is -2/3, and the intercept is -2. To graph this, we go down 2, and then we apply the slope, which says we go down 2, forward 3, or we could rise 2 and go back 3. Then we have to determine if it's solid or dashed. This comes from the inequality. Because it says less than or equal to, the line is solid. And then we determine the shading. The shading occurs, it says y is less than, so we would shade below. In my class today, I talked about if we were not sure how to determine about the shading, then we would pick a point. For example, we would pick 0, 0 and plug that into our equation. So it would read 0 is less than or equal to -2/3 times 0 minus 2. This becomes 0. So you get 0 is less than or equal to -2. Because the statement is not true, it means this point is not part of the shading. All of these points are part of the shading. Any of these points on this line would be part of the shading, but any of these points outside above the line would not be part of the shading. Our second equation, we're going to isolate the y. To isolate the y, we're going to divide by -3. Make sure to divide it to all pieces. When you divide by negative, it flips this inequality, or sometimes they say it reverses the order. So you're left with y is greater than these 3's divide out as well as those, and you get 1x or just x, and then 6 divided by 3 is -2. From here you can pick out your slope is 1 over 1. Your y-intercept is -2. So to graph that, we start at -2 on the y-axis, and we apply our slope up 1 over 1, up 1 over 1, and then we look back at our inequality. Our inequality here reads y is greater than. Because it's greater than, we have a dashed line, and then we determine if we shade above or below. It says y is greater than, so we would shade above. Now, again, we can pick a point to verify. So I would pick right here at 0, 0 and plug that into my original equation. My original equation has -3 times 0 is less than -3 times 0 plus 6. So this becomes 0. That's 0 plus 6 is 6. So this says 0 is less than 6, which is true. And because it's true, it means that this point right here is part of the shaded region. Okay, our third example says to graph each linear inequality using intercepts. So I did this intentionally so that we could practice finding intercepts. To find the x-intercepts, remember that y has to be 0. So we're going to go into the equation and substitute the y was 0. And instead of solving the inequality, I'm going to replace that with an equals, only because we don't really need to use the inequality to get the intercepts. So this becomes 0. We're left with 3x equals 6. To solve this, we divide by 3. The 3's divide out, and x equals 2. Okay, for our y-intercept, we replace the x value with 0. So in our equation, we have 3 times 0 plus 2y, and we're going to use the equals again instead of the inequality. This goes to 0, and we're left with 2y equals 6. To solve that, we divide by 2. The 2's divide out, and y equals 3. So it gives us the ordered pair 0, 3. To graph that, we go over 2 up 0 for the x-intercept and over 0 up 3 for the y-intercept. Now, before I go to graph the boundary line, we look at the inequality. Because the inequality says less than or equal to, it is a solid line. And then to determine which region, call it region 1 or region 2, we're going to pick a point. And I'm going to pick 0, 0. Because it's not on the line and it's really easy. So with that 0, 0, I put that into the equation. 3 times 0 plus 2 times 0 is less than or equal to 6. This becomes 0, this becomes 0, so 0 plus 0 is 0. And then I'm going to read this inequality. 0 is less than or equal to 6. This is true. So because it is true, it means that that point is part of the solution. So I'm going to shade in region 2. And what that means is any point on this line or within this region, they are considered to be solutions to that inequality. Okay, your last inequality, again, we're going to practice using the intercept. So our x-intercept is when the y value is 0. I'm going to put 0 into my equation for y, and I'm going to change this to an equals instead of an inequality, and this goes to 0, so I'm left with 4x equals 4. To solve that, we divide by 4. 4's divide out on the left, and the 4's divide on the right to give you 1. So we have an intercept at 1, 0. For our y-intercept, we now replace the x with 0.
All teachers were...
Sorry, that was the intercom coming over. Anyway, we go into the equation, replace the x with 0. And this will go to 0. You're left with -2y equals 4. Divide by -2. These 2's divide out, and you get y equals -2. and that leaves us with an ordered pair at 0, -2. To graph those, we go over 1, up 0, and then over 0, down 2. Before I draw the boundary line, I'm going to go back to the inequality. Right here it says it's just greater than, so it's a dashed line. And then to determine region 1 or region 2, which direction to shade, I'm going to pick a point. I like 0, 0 because it's not on the line, it's easy to work with. And I put 0, 0 into the equation. 4 times 0 minus 2 times 0, is this bigger than 4? So this goes to 0, 0 minus 0, 0. Is 0 greater than 4? No. So that means that point is not a solution, and we would shade in region 2. And that is all I have. Your assignment is graphing the linear inequalities. Good luck.